Hi, my name is Greg Charvat, and today we are going to look through solid concrete walls. We've developed a phased array radar system that can look through solid concrete walls. Our objective is to aid the urban warfighter to increase his situational awareness. Rather than using visible light to look through walls, which is not very effective, we instead use a microwave wavelength of approximately 10 centimeters. We radiate a very small signal from this phased array radar into this solid concrete wall over here. Of the radiation that we emit at the wall, only 0.6% of that actually gets through the wall itself. Now, what little energy scatters off the humans behind the wall has to then go back through the wall. When it goes back through the wall, it again loses 99.4% of that energy that was scattered off the humans. And now this extremely weak signal comes back through the wall towards our radar where we receive it.
So what the radar does is it virtually simulates 44 beam combinations along the aperture of the radar. So what the National Instruments Board does is it actually controls the switching pattern of those beams and forms a continuous virtual array of 44 beams, which gives us this linear aperture. And all those beam combinations and beam samples are then A to D and acquired by that gaming PC, fed into the imaging algorithms, and then displayed in the user interface that was created to visualize that 10 frames a second of the target scene behind the wall.
Our antenna is made up of lots of little antennas. It's a piece of printed circuit board. It happens to be white, and it has these gold traces here, okay, that are conductive. And what happens is there's a piece of coax cable, like your cable television cable, that's soldered to the back of this antenna, and it feeds a microwave signal from our transmitter, and that signal is radiated outward across these two gold-plated metal traces. And that signal propagates then through free space to the wall, off the targets, and then back. For the receive antenna, what happens is microwave energy comes in to this antenna, and it's collected all the way down to the back here and fed into a coax cable where we discriminate and analyze it digitally later.
This is the transmit chassis, which basically sends signals out. Those are the real signals in real time. So when this one is high, this is what's received, and then this is just it resetting itself. So right now you see little signals being received because it's going through the wall and back.
Now, the radar does not see things as we humans see things. This radar image is a top-down view. The image plane is in the range away from the radar and versus cross range across the radar. So what you're seeing is actual location away from and across. Currently, when you look at some of the data from this radar system, what you see are a little red blob when you have one target behind the wall. When you have two, you'll see two red blobs, and the blobs move around. What we would like to do in the near future is we want to implement a detection algorithm where instead of seeing the blobs, you'd see little crosses or squares.